Morning, all of you. My name is Dr. A. Nagarjuna, Associate Professor, Department of H&S. Today, I want to discuss a topic on bipolar junction transistor. Previous class, we discussed about PN junction diode and GNR diode. Today, we discuss bipolar junction transistor. These all devices, PN junction diode, GNR diode, transistor, all are manufactured with semiconductor material only. Now, what is a transistor? Transistor is a semiconductor device having three terminals, two junction. One is junction 1, junction 2. One is emitter based junction. Another one is collector based junction. The main functions of a transistor are amplifying. Another one is switching. It is also called a switching device. We have two basic amplifying devices. One is current amplifying device and voltage amplifying device. For voltage amplifying, we use FET, field effective transistor. For current amplifying, we use transistor. These are the two main amplifying devices. And the base simple difference between a diode and a transistor is diode is a two-layer, one-junction device. Transistor is a three-terminal, one-layer device. Diode is a two-terminal, one layer or one junction. It has transistor is a three-terminal, two-junction device. These are the parts, three terminals. That is emitter, base, collector. And these are the two types. We have two type of transistors, PNP and NPN transistor. We observe the difference in emitter. According to this arrow mark, we can observe the difference. It is inside, it is outside the device. This is the NPN PNP transistor construction. This is a NPN transistor. This is a PNP transistor. Emitter, collector, base in NPN. In this emitter, again collector, base. It is the sandwich of two semiconductors. Sandwich of two semiconductors. That is two N semiconductors. Junction simply sandwich of one type of semiconductor material between two layers. In NPN, two N semiconductors, in between have P semiconductor. In PNP, have two P-type semiconductors, in between N semiconductor. In PN junction diode, only one P, one N junction, one N semiconductor. In this, three NPN or PN. In this emitter, this forms the left hand section of region of a transistor. And what is this? It is a more heavily doped in comparison to other two regions. Emitter is more heavily doped than other two. Why? Because emitter, we observe that emitter is the connection, immediate connection of source, that is battery, easily picking the voltage. Heavily doped the emitter. Base, middle section of a transistor is known as base, middle section, in between emitter and base. This base, middle section in NPN, two N sections, the middle is P. In two P sections, the middle one is N. In this two P types, N. That is the N is the base in PNP. P is the base in NPN. The middle section of a transistor is base. This is lightly doped. That is 10 power minus 6 meters. Very thin. The other two. Collector. The right hand section of a transistor. The right hand section of a transistor is called as collector. The collector is moderately doped. We observe that depending upon the doping, the depletion layer will breaks. Are you aware about depletion layer, breakdown, all these things? Breakover voltage. We observe that a PN junction diode as well as GNR diode. Depending upon the doping, easily breaks the depletion layer. Emitter is heavily doped, base is lightly doped, and collector is moderately doped. These are the various transistors available in the market. Depending upon our application, depending upon our circuit or projects, we can use the PNP, either NPN transistor. In general, we are having PC107 and 518, different type of transistor available in the market. Then what is the difference between PNP and NPN transistor? The first difference is symbol. Depending upon the arrow mark in the emitter. Now, other one is the base is lower voltage than the emitter current flows from emitter to collector. In PNP, according to the symbol or construction or the diagram, structure diagram, base is lower voltage than emitter. In this NPN, base is higher voltage than emitter. Base to emitter is low voltage. Base to emitter is high voltage. That is the difference. Second one is small amount of current allows from emitter to base. Why? Because you know that according to Ohm's law, V is proportional to I. At lower voltage, we are applying lower voltage. We are getting small amount of current flows from emitter to base. Again, higher voltage applying small amount of current allows also flows from base to emitter. And emitter is heavily doped compared to collector. This is emitter is heavily N doped. Why? Because both are N. 2 N semiconductors, 1 P. That is 2 N's. Emitter is heavily doped. In this P is heavily doped. Emitter junction, not collector type of terminal. Next, the base width is small compared to minority carriers. Already you know that majority and minority carriers. In P-type semiconductor, what are majority charge carriers? Holes are majority charge carriers. In N-type semiconductor, free electrons are majority charge carriers. And what are the minority charge carriers? Electrons are minority charge carriers in P-type semiconductor. Holes are minority charge carriers in N-type semiconductor. This majority minority plays a vital role in the junction or in the depletion region. And next one is voltage at base controls the amount of current flow through transistor. Voltage at base controls amount of current flows through transistor. Again. Okay. Next last one is follow the arrow to see the direction. Again, direction. Depending upon the direction, we can identify the type of transistor. Next, what are the basic applications of BJT? In the first slide itself, we said that transistor used as a amplifiers and switching operators. Many amplifiers. Suppose we are using a mic. In the class itself, we are using a mic or head in the mic. Suppose here in a classroom there is no need of mic. Suppose in auditorium or in any big uh, speeches or any type of information passing from speaker from stage to the last person, it needs mic. Mic connects with a device called as amplifier. Then what is an amplifier? Amplifier is a device which can increase or amplify the signal. That means given signal. Amplifies means increase the level of a signal. And a switching device. Then amplifiers are being used in various oscillators. In the laboratories, we use function generators. Function generators generates signals or oscillations. Modulators in communication. In intermediate, last unit, I think, second year. Communication, and that modulation and demodulations. Demodulators also called as detectors. In this device also, we can use transistors. In the digital circuits, in the intermediate, you also read about the digital circuits or gates and NOT gate, NOR gate, NAND gate, and the devices and the components we use transistor. Transistor also called as NOT. That means it's a NOT indicates reverse. If input is high, output must be low. If input is low, output must be high. This is called as switching, on off. This transistor is also used as a switching device. And transistor biasing. We observe that have two diagrams. One is A, one is B. Both, one is related to PNP transistor, another related to NPN transistor. In this PNP, you see that the emitter base junction is always forward bias connection. In emitter base junction, emitter base, this emitter base junction is always forward bias connection. Already you know that. What is forward bias connection? What is reverse bias connection? Already you read in the PN junction diode. What is forward bias connection? The positive of a battery is connected to P type semiconductor. Why? Because in P, majority charge carriers are holes. And in the negative terminal of a battery connected to N type semiconductor. It is called as when the majority charge carriers are free electrons negative. Okay, this type of connection is forward bias connection. That's why emitter base junction is always forward bias connection. It is same as PNP as well as NPN. You observe the diagrams. This positive to P type, negative to N type. In NPN, negative to N type, positive to P type. Same polarity applied to that semiconductors. And next one is culture based junction is always reverse bias connection for both PNP as well as NPN. We observe that this is we observe that positive terminal of a battery giving to N type semiconductor, negative terminal of a battery giving to P type semiconductor. For that, this positive in majority charge carriers are free electrons. We are applying free electrons to positive. Next, negative to holes. Holes having positive charge. For that, connection is called as reverse bias connection. Then this base collector junction is reverse bias, both PNP as well as NPN transistor. After this connection, what he said that for this purpose, a battery VEE emitter is connected between emitter and base while a battery VCC is connected between emitter and base, while VCC is connected between collector and base. The emitter base junction of PNP transistor is forward bias by connecting the positive terminal of a VE to negative. Then why biasing? At a time, we are not able to operate either AB or BC. AB means emitter base junction or base collector junction. If we taking input characteristics or emitter base characteristics or junction, this base collector value must be constant. Either 1 volt, 3 volts, 5 volts, we put it as constant by on the junction. When we take output characteristics or base collector characteristics, this value must be constant. This must be constant. After that, we are taking the values. If the value must be 1, then we operate the value from 0.1. According to the PN junction diode, we observe that at germanium, the breakover voltage is 0.3. At silicon, the breakover voltage is 0.7. That's why we start operating from 0.1. 0.1, the current must be 0. 0.2, current must be 0. 0.3, current must be 0. After 0.3, the value is 0.001. Then it can be confined that it is germane. Otherwise, after 0.7, it is silicon. Again, another case we can observe. After 0.7, it must be 0. 0.8, 0.9, it must be 0. Then you won't get any current. That means the transistor have problem. Then you go to lab assistant and took another transistor and start the procedure again. Finally, after 0.7 or 0.3, the current start increasing. In this process, you know very well in the P-type semiconductor and N-type semiconductor. You can write an examination, case 1, transistor biasing or operation. In case 1, this is the biasing, it is the construction. P-type semiconductor, N-type semiconductor, again P-type semiconductor. This line is a depletion layer. When we increasing continuously, the voltage increasing continuously after breakover voltage, the depletion layer breaks. In this emitter base junction also same, and collector base junction also same. Collector base junction also same. What should be done after depletion layer breaks? After breaking of depletion layer breaks, these free electrons moving towards holes. Again, holes towards free electrons. After that, electron hole pair occur. Electron hole pair occur. When electron hole pair occur, we get potential difference. From this potential difference, we can note the current. We can note the current through the transistor. Then, what are the points observed in the forward bias connection? The first one is connection. Connection means P-type semiconductor to positive terminal, N-type semiconductor to negative terminal. After depletion layer breaks, when depletion breaks, the input voltage or source voltage is more than breakover voltage. After breaks, the electron hole pair occurs. The majority through the current conduction through majority charge carriers in milliamperes value. In reverse bias connection, current conduction through minority charge carriers in microamperes range. Why? Because through minority charge carriers, it is difficult to break the depletion layer. then it gets less value, that is microamperes current in the reverse bias connection. These are all points you know in the PN junction also. But what the difference is? We have two junctions at a time in the same device. That's why in this also giving that a transistor transfers a signal from low resistance high resistance. Then this forward bias emitter junction has low resistance. Emitter base junction. Low resistance. Why? Because high current. According to Ohm's law, you know that. According to Ohm's law, V is equal to IR, I is equal to V by R. That is, the resistance is inversely proportional to current. Low resistance part. And in reverse bias, that means collector base section has high resistance. Why? Because low current. Low current, high resistance. High current, low resistance in forward bias connection. That's why a transistor, a weak signal is introduced in the low resistance circuit from high resistance circuit. This type of working observed in the PN junction. This is similar to NPN transistor also. What is the final equation we get? Already in the starting, I said that transistor is a current control device. That's why emitter current is equal to sum of base current and collector current. Same observed in NPN. Just the construction is difference in NPN transistor. And next one is sign conversion. It is according to the sign conversion, the emitter current IE is positive. That means in the previous we observed that the equation IE is equal to IC plus IB. Then we get emitter current IE is positive, while base current IB and IC both are negative in PNP and both are positive in NPN, base and collector. From this we get this equation I is minus IC minus IB. Why? Because this is the reverse current we get minus. This is the reverse connection. This is forward bias connection. That we get this equation. Another important thing, next topic is configurations. We have three different configurations in the transistor. Three different configurations. That is common base configuration, common emitter configuration, common collector configuration. Common base, common emitter, common collector. This common indicates whatever the terminal ground, whatever the terminal grounded in the device transistor, on that name or connection, we name it as common. In common base connection, the base can be ground. Common emitter configuration, emitter must be ground. In common collector configuration, collector must be ground. This diagram is related to PNP transistor. This is related to NPN transistor. And again we observe another difference. This is input. It indicates battery connection. This indicates AC connection. That is given from function generator, signal generator. It is a signal. We are observing, we are giving positive peak one time, negative peak another time. This is also a type of source. We are giving both input as through battery as well as signal generator. That's why shows one input through PN junction, PNP transistor, one type of connection in NPN transistor. We observe the output as digits in the NPN transistor when we can apply battery. When we apply signal, when we apply signal, it gets a output also signal. Signal can be observed in the rectifier, in the intermediate itself. We get the ripples, positive peak, negative peak. Already you are aware that this common. It is a common base, common collector. You observe that PNP. Again, PNP, PNP. Base is ground. NPN, E must be ground. Collector must be ground. And this emitter base, again we observe that base must be ground. The input is changes, but the terminal must not change. Base must be ground, emitter must be ground. Again, collector must be ground. These are the very important configurations. Depending upon the type of circuit, this transistor used as a amplifier. On that amplifier, we use a common emitter configuration than other two configurations, preferably. And also, we prefer NPN transistor than PNP transistor in many of electronic circuits. Why? Because in the differences we recollect the differences. This NPN transistor voltage at base controls amount of current flow must through transistor have higher voltage. This type of reasons we prefer NPN transistor in different type of circuits than PNP transistor. Also CE configuration than other two. Now we see the characteristics. When we apply emitter base junction, that is, see that BE, VBE, we are applying emitter base junction, we get this type of results. This is similar to normal PN junction diode. Up to breakover voltage, there is no change in the graph. After breakover voltage, the current must be varies, increases at in the circuit itself. This is the input and output characteristics circuit. We are applying input means we are increasing the values in this side. This voltage must be constant. We are varying these values. This battery must be constant. We observe that at three different cases. At collector emitter, a collector value is CE is 1 voltage. This graph. For 5 volts, we get this type of graph. For 10 volts, this type of graph. For all these, we get the current from base current. The graph drawn in between VBE, forward current, that is forward bias connection. Base emitter junction, forward bias junction, current is IB. What are the points we observe? The characteristics resembles through forward bias diode curve. And that means it is similar to normal PN junction diode curve. This is expected because the base emitter section of transistor is a diode and it is forward biased. Same. And in case IB increases less rapidly with VBE as compared to common base configuration, this shows that the input ratios of common emitter. Why? Because IB increases rapidly. So input ratios must be high of common base. We get input resistance. Input resistance taking from V by I. You know very well Ohm's law. V is equal to IR, R is equal to V by I. Same form. And output characteristics. Output characteristics means it is related to collector emitter configuration or collector emitter junction. The current must be collector current, IC. In the input characteristics, voltage is VBE, emitter base junction, current is base current. In this output characteristics, collector current and again IC. In general, the transistor working in three stages. That is cutoff region, active region, saturation region. Saturation region. According to the breakover voltage formula, after breakover voltage, we are applying after breakover voltage, the the current conduction starts. We know very well. After up to breakover voltage, the current must be zero. That is called as cutoff region. That means up to zero. After that, these lines, indicated lines, this is called as saturation region. It is called as saturation region. That means input increasing continuously. This continuously increases. After peak value, after there is no increasing of the current. When we increasing continuously after 6 volts, also 6 milliamperes, there is no change in the current. That is called as active, a constant value of increasing. Increasing region is saturation region. After that, active region. In these three stages, the transistor may works. Cutoff region, saturation region, active region. This can take 5 stages. At the current must be 0. On that, we get VCE. We get applied voltage in the input characteristics constant as current. IB is equal to 0. IB is equal to 10 microamperes, 20 microamperes, 30, 40, 50. Y minus means reverse current. Again, output resistance. And that input characteristics, we get input resistance. In this, output characteristic is output resistance. So we get this value. And last one is these are the various numerical problems based on the formulas. That is HRE, HE is a hybrid parameters values. We can discuss in the next class. So transistor as an amplifier. In the first slide itself, we said that transistor is acting as an amplifier. This is a device. We are giving VEE, that means emitter voltage. It is a VCC, applied voltage. We know that it is a cell, it is a battery. We are giving more voltage. It is a battery. It is a fixed value, 2 volts, 4 volts, 6 volts, 8 volts, fixed value. In general, in our laboratories, available from 0 to 30 volts. 2 or more cells, we are giving a more voltage. It is a signal. In the NPN transistor, in the previous slides, we see that in NPN transistor configurations, we see the signal. That means, what is an amplifier first? Amplifier, that means amplifier is a device which can improve the given signal. It is called as an amplifier. This amplification can be done through this amplifier. We are giving the input signal positive. Already we said that you know that NOT gate, when we give the input as high, output must be low. When we give input low, output must be high. High means positive. We are giving positive to the this value. We get output must be low. When we give negative peak, that means low value, reverse biased value, the output must be high. That means VEE is not connected in the circuit. Now for negative peak of applied signal, the emitter base junction will be reverse biased connection. Then this is desirable because achieve faithful amplification. Then for positive peak we get high value, for negative peak we get less value. This same result observed in rectifier also. Rectifier is a device which converts DC to AC to DC. That means high value. Then a small change in signal voltage produces an appreciable change in emitter current because the circuit has low resistance. At low resistance stage also increase the value using transistor. This is the major role played in the amplifier. Now, any doubts we can clarify in the next class. Okay, thank you for listening. Thank you.